In this video, I am going to derive the theorem of parallel axis. I am going to talk about the theorem of parallel axis as well as I am going to derive an expression. For that, I need to have a body. Theorem of parallel axis is applicable to any shape of the body. Therefore, here I have taken a random shape. It is a body of any shape. Here, a body of any shape. The axis of rotation passing through center of mass. The body is rotating about the axis passing through the center of mass. Now another situation where the axis of rotation passing through the point O. Point O is any other point on the body other than center of mass. So O be the any point present on the body, same body other than center of mass, and the body is rotating about the axis passing through the point O. So in parallel axis theorem, we talk about two axes. One is a passing through the point C, the center of mass. Another is passing through the point O. And at a time, only one axis of rotation is present. If both axes are present together, the body cannot rotate. So I want to clear the point. At a time, only one axis of rotation is present. But in the diagram we have drawn both the axes because we need to derive mathematical expression. So we have to correlate the mathematics of axis passing through the center of mass and axis passing through the point O. Let IC be the moment of inertia of the body about the axis passing through the center of mass, and let I naught be the moment of inertia of the body about the axis passing through the point O. Remember that both axes are parallel to each other and the distance between the axes is equals to h. Now consider a point D present on the body, and at the point D a very small mass dm is present. So at the point D a very small mass dm is present. Now join the points O and C and extend it, and join O and D, and from the point D draw a projection on the line OC extended, cutting at the point N. Join the point C and D, call this point as a and it is a C and it is a B, and call this point as a E, it is a O already, and F. So we have the axis ACB. We have the axis ACB and we have axis EOF. So we have the two axes about which the body is rotating one axis at a time. If axis ACB present, then axis EOF is absent. If axis EOF is present, axis ACB is absent. Only one axis is present at a time about which the body is rotating. Now distance of elemental mass dm from point C equals to distance dc, and from point O equals to distance OD. Now moment of inertia of elemental mass dm about the axis passing through the point C, that is denoted by small I and C, suffix is the C, IC, equals to mass present at the D, that is dm, and square of distance dc square, because moment of inertia is nothing but mass multiplied by distance square. Therefore, IC equals to dc square dm. Now, for entire body, moment of inertia about the axis passing through the center of mass is given by IC equals to an integration of above expression, that is dc square dm. Call it equation number 2. Similarly, moment of inertia of elemental mass dm about the axis passing through the point O is given by I naught equals to mass present at D, that is the dm, mass dm, multiplied by square of distance OD square. And for entire body, moment of inertia about the axis passing through the point O is given by I naught equals to integration of OD square dm. Call it equation number 3. From figure, OD square equals to ON whole square plus dn whole square, that is by Pythagoras theorem. Therefore, I naught equals to integration of ON square plus dn square multiplied by dm, that is the integration with respect to dm. But ON equals to OC plus CN. Therefore, I naught equals to integration, in place of ON, now we'll writing OC plus CN whole square plus dn square, bracket close, with respect to m, that is with respect to m. Now this is equals to integration. Here applying a plus b whole square formula, that is equals to a square plus b square plus twice ab. Applying this formula, so we get OC square plus CN square plus 2 OC dot CN plus dn square, bracket close, with respect to dm. Rearranging, first writing CN square and plus dn square. Can you guess why I am writing them together? That is CN square plus dn square. Meanwhile, you guess out why I am writing CN square plus dn square. After that, OC square plus 2 OC CN, bracket close, with respect to dm. From figure, this is a right angle triangle. So here we can apply Pythagoras theorem, that is CN square plus dn square is equivalent to dc square. Here CN square dn square, that is equivalent to dc square. Therefore, CD square are dc square one and the same, plus OC square plus 2 OC dot CN, bracket close, dm. From figure, distance OC equals to H. Therefore, wherever the OC is there, you can write down H. Therefore, I naught equals to integration C d square plus OC square. OC square nothing but H square plus 2H Cn bracket close dm. Now separating integration terms, I naught equals to integration of CD square dm plus integration H square dm plus integration 2H Cn dm. But IC is nothing but integration of DC square dm. That is from equation number 2. Therefore, here CD square dm shall be replaced by IC. Therefore, I naught equals to IC plus H square integration dm plus 2H integration Cn dm. From figure, NC is the distance of the point from the center of mass. So this is the distance. NC is the distance of the point from the center of mass. Since mass distribution is balanced about center of mass, therefore integration Cn dm equals to 0. Therefore, I naught equals to IC plus H square, and integration of dm is nothing but entire mass of the given body. Therefore, H square multiplied by m plus 0 implies I naught equals to IC plus m multiplied by square of distance. Now let us summarize the point. We are having two axes, they are parallel to each other, and we want to find out moment of inertia of the body about the axis passing through the point O. We want to find out I naught, and we know that moment of inertia about the axis passing to the center of mass, that we know IC value, we know the mass of the body, and we know the distance between the two parallel axes. Then I naught equals to IC plus MH square. This expression is nothing but mathematical form of parallel axis theorem. So here is a statement of theorem of parallel axis. The statement is like this: moment of inertia about any axis which is parallel to the axis passing through the center of mass is equal to sum of moment of inertia about the axis passing to center of mass and product of mass and square of distance between parallel axes. So this is what the statement of theorem of parallel axis. Friends, the theorem of parallel axis is very important when you engineering point of view, because in engineering, like solid mechanics, strength of materials, and when you deal with the moving part in a machine, like dynamics, where you design the various machine parts, the moment of inertia plays an important role. So do this topic very well, strengthen the topic, solve many difficult problems based upon the parallel axis theorem. I ensure you that you will be really benefited. You will understand engineering more better way. Meet you again with next topic. Before saying goodbye to you, I would like to request you like, share and subscribe the channel. Meet you again with next topic. Till then, wish you good luck. All the best.